Hello, everyone, and welcome to Element 14's Google Hangout on Douglas Wong's recent vehicle simulation project. I'm William Polk, the Public Relations and Social Media Manager for Newark Element 14, and I've got a couple of noteworthy folks who can further discuss this project here on the Hangout with me. From my left to right, we have Christian DeFeo, who is the eSupplier Manager at Element 14. We've got Douglas Wong, who is obviously the engineer in this project. He was the winner of Element 14's Smarter Life Challenge. He built a smart thermostat with speech recognition and Bluetooth connectivity, among many other features. Hi, Doug.
Hi.
And we have Jason Kribner from Texas Instruments as well, whose resume is quite impressive. He's in charge of open platform technologies at Texas Instruments. He is the co-founder and board member at BeagleBoard.org, at the BeagleBoard.org Foundation. Excuse me. Jason, did I leave anything out? Anything else you want to mention?
That's good for now. That's all that's relevant here.
All right, sounds good. So at this point, Christian, I will kick it over to you to talk a little bit more about the project and what the intent was, and some of the technology that was used.
Okay. This is all part of a partnership that we at Element 14 have been building with Texas Instruments and Cisco Systems. And the idea is that, at least at the beginning of this year, the Internet of Things was on everybody's lips. In fact, we went to, Doug will remember that we all went to Embedded World, and you couldn't escape these very large signs that said from Intel, the Internet of Things starts here, and from ST, the Internet of Things is they had all sorts of things about the Internet of Things as well. And what we were hoping to do, though, was rather than talk about the Internet of Things in very generic terms, was to get behind building solid Internet of Things applications. And so we worked with Texas Instruments and Cisco, and one of the first things that we identified that we wanted to do was to build an IoT-enabled vehicle simulation system. At the moment, if you are a developer of vehicle apps for your car, the systems by which you can test these apps are fairly limited. There's a proprietary box which costs a substantial amount of money, and prohibitive enough for the inventor, the amateur inventor, or the modestly financially capable inventor to think twice about doing it. And so the thought was that why don't we open this up? Why don't we have an open source solution that allows it to be an IoT-based application? And so Cisco and we NTI created a brief, which we then passed on to Doug, and he has been working on it ever since. And we're starting to see some results, and particularly its work with the BigOnBlack. And so we're seeing that this is opening up a whole new world of application development. And so this was the impetus behind it, and this is what we've been hoping for that Doug has been working on.
Great. Thank you for that explanation. And I want to go over to Doug now to tell us a little bit more about the project, your efforts, and what you have been working on.
Sure. So as Christian mentioned, the vehicle as a platform for development is a pretty key component in everyday life. One of the largest technology expenditures that the average consumer makes is on their vehicle. And of course, the vehicle has all kinds of computers in it already and all kinds of data available. So it stands to reason that there would be a lot of interest in making applications that would utilize the data that's available in vehicles and the infrastructure that's there. So far, it's mainly been used by technicians for repairing vehicles, but there's the potential to have a huge infrastructure around vehicles and communications between vehicles and between people and vehicles, and making use of the information that's available. So this platform that we're trying to develop is to allow people to develop applications and instruments that use vehicle infrastructure to sort of make our lives better and get vehicles connected to people and connect vehicles to the internet or whatever you might come up with. But so it's not actually a simulator that you would drive around like a vehicle simulator that you typically think of, where the person is being exposed to the things that you'd get exposed to when you're driving a vehicle. This is a simulator that looks like a vehicle to another computer. So if a computer is developed that talks to the vehicle, like the onboard debug port in a vehicle, which has all the information about the engine parameters. So this simulator would look like a vehicle to any instrument like that. You can buy all these, already buy these engine and or vehicle diagnostic machines that can talk to your vehicle and tell you what's wrong with them, give all the trouble codes and so on. And this simulator would allow those types of devices to hook up, and it would just look like a normal vehicle to them. But it also opens up the capability of developing any kind of other instrument that might talk to a vehicle. And the simulator is going a little bit beyond what's just in the vehicle. So we wanted to make sure that we could have some even more unique applications that would or could be developed. So one of the things we're doing, as Christian mentioned, we started out with the BigOnBlack as the computer platform that we would use for this simulator. That is going to allow us to make it portable, and you can actually run this thing in a vehicle, because the way we're going to do the initial simulation is not by trying to compute all the parameters in a car. We're going to mainly record what the cars are doing. So we'll take it on a real car and record all the information that the car has in it, and create a library of characteristic trips which have the normal data that you would associate with the trip, and these trips can be played back in the simulator in your lab. But that aspect of the device where we have to put it in a car and record what's going on is beyond the simulation. This is a second aspect of this project where we're actually making a vehicle trip recorder, and the trip recorder is going to record not only the information that's on the debug port in a vehicle, but it will allow us to record some of the other things that you might find. So we have a sensor suite that's been designed to work on a cape that plugs into the BigOnBlack. And we have some extra communications there as well. We have a little display in that cape. So the sensors that are on there are the typical things you might find, like accelerometers that would allow you to tell the G-forces on your car. We have a light sensor and so on. So there's all the angular rates, all the linear accelerations, and even the magnetic compass readings, so you can tell the direction. So normally your car is not going to tell you where it is or what direction it's going. So these sensors allow the recording device to not only record vehicle parameters, but some information about the environment that the vehicle is in. And you could even, of course, use a video camera and at the same time record a video of the trip. So you could have a fairly complete record of the trip for playback in the lab. So that's sort of a brief overview of what we're trying to do here. There's two main aspects of it. One is a playback of a real trips with all the data that's you can get from a car plus a few other sensors. And the other one is, of course, the recording function, so that you can actually record these trips for later playback.
And so each of these devices, so the simulator, is that just got a CAN interface that's capturing all the or that's looking like a car, so it's mostly software and what looks like an ODB2 port. I guess is that the right protocol, and is that really all there is to the hardware when it comes to that simulator?
That's correct. There are a couple of CAN connectors on here, or OBD2 connectors, so that you can plug this device directly into an OBD2 port in a car, or you can plug in any device that would normally plug into that port. So there are 2 ports on the CAN bus that's coming out of the BigOnBlack, and it also has a Bluetooth wireless interface, so that you could talk to for example, a wireless OBD interface if you wanted, or you can also connect it to your smartphone through the Bluetooth.
Well, in all these cases, though, it's acting like the client. It should be acting like the client, right? It should be acting like the car, the source of data. Is that right?
It's acting like the car is the source when it's in the recorder mode.
Okay.
When it's in the simulator mode, it's actually playing back and acting like the car.
Okay, so you have one device that's doing both functions. So you're adding all these different sensors and everything to provide the record function onto the main simulator design that you've already done.
Yes, we haven't actually decided whether it can be fit into a single device, both applications. It might be a separate load of software for the simulator versus the recorder. We haven't figured out whether it's feasible to put it all in one yet.
Yeah. So when you're describing it, it's a little bit difficult for me to keep them separate, because I think you're kind of switching back and forth to talking about the recorder and the simulator a bit. So it sounds like you've done a lot of work on both already, but the recorder is maybe a little bit still has a little bit more work to do, and the simulator is pretty close to done. Is that?
Well, so far what we've done is we finished building the cape. So we designed this cape that fits on the BigOnBlack. It has all the sensors, displays, and user interface on it. So there's also a keypad, so that we can go fully standalone in a mobile environment. So that cape would only be normally heavily used in the recorder mode.
Right.
In the playback mode, we're mainly using the CAN bus to supply information to somebody else.
Right.
So the software has been the next big stumbling block, or not stumbling block, but the next big effort. Trying to get the operating system to work with all kinds of drivers for all these sensors and so on that we've been interfacing to. And it's been quite a learning curve, mostly for my software partner. But so we ended up using Ubuntu instead of the Angstrom load, which was sort of the thing we started with.
Yeah. These days, I'd recommend the Debian.
Yeah, we have, I guess, the slightly older version of the BigOnBlack. The newer one has the 4 gigabyte flash capability, so the Debian would fit easier in that. We haven't tried it with Debian yet, so I think eventually we will have to go there. I don't think that's really much of an option.
You can run off the micro SD. You can also, if you flash it onto the 2 gigabyte, which it still goes onto the 2 gigabyte, you can delete a bunch of documentation and like web browsers and other things that you wouldn't use in your system. So it'll fit on the 2 gigabyte, and then you start deleting a few things, and you can get down to a pretty slim system.
Yeah, I mean,
Chrome browser, for instance. I mean, that's just.
Yeah, we haven't tried that yet, but of course that's certainly something we would like to do. He's also a bit trying to wrap his head around how to get all this data that we're recording to fit on one of those memory devices. So
right.
There's some of that in his thoughts as well as just storing the operating system.
Yeah, data logging on an external USB stick or on you know, and the micro SD card can give you a lot more room. Um, but it sounds like it sounds like you're pretty far along. It'd be great to see something. You know, if you've got
Yeah.
any boards to show, I'd love to. I love visual aids.
Yeah, you and me both. So I can send pictures of the hardware. It's a cape with all kinds of stuff on it. Uh, he hasn't got any good pictures of his software running yet, but what he has got running is all of the interfaces to all of these sensors and all of the peripherals that are on the cape, and including the CAN bus. So he has demonstrated that all the hardware is working. He's got drivers that run everything. And for example, the display, which is an SPI LCD, he had found some, driver or sample program on the web someplace, but he's ended up. It was sort of driving this SPI through bit banging and stuff like that, and he's kind of a purist, so he's
Yeah.
converting that all to run from proper SPI.
Well, there's a depending on what type of controller the SPI display has in it, there's frame buffer drivers, which is generally the way I'd recommend doing it, is using a Linux frame buffer driver for your SPI device. And if it's like I don't remember the name of the common controller, but it's something like an ST7735. I don't really know who that, but that's a really common controller in these SPI displays.
Well, this is one of the oldest SPI displays you can get, so it's one of those really cheap old Nokia things.
Yeah,
But
I've got actually a couple of them. This one's an SPI display, and then this one's nice and cheap. This is a little SPI display, and these both I think use that same controller, and you can get a frame buffer driver for it. I know a lot of people do bit bang it, or even just use SPI dev and then software to write to it.
I think he's switching it over to run from SPI and full DMA, so it's going to be fairly autonomous.
Yeah, you might want to go the one step further and go to the frame buffer driver. Matt Porter did a good example of code for that. We actually ship with an SPI LCD driver. I think it works with a couple of the Adafruit LCDs. They have a 1.8 inch SPI LCD that you can just wire directly and just load that driver. But it's there's still a little work to get it to work with other different display sizes and different controllers.
Yeah, I mean he had been struggling to get the platform all ironed out because there was a lot of issues with different versions of everything not running and having problems. But I think and of course he's at the stage now where he's got his development environment working properly and pretty well. He had some problems cross compiling it on a PC, so I think he's actually using the BigOnBlack itself now as the for everything.
Yeah, I do most of my development natively myself. Even kernel drivers. I don't rebuild the kernel on the board, but if it's a kernel driver, it's not too hard to load the headers and actually rebuild an individual driver on the board itself.
Yeah, I think that's what he's doing now. So it's he says it's working a lot more seamlessly.
Yeah. And if he has questions, there's an IRC channel. We usually have there's usually a couple hundred people in the IRC channel at any given time, 200 or 300 people, and usually somebody's around that knows something. I'm on it on pretty much a daily basis, not all hours of the day, but you can find me on the IRC channel to get a live chat. There's also the mailing list, and if you don't get a response on the mailing list, make sure to CC me and ping me, and I'll make sure that you get a response. Most of the time I wait a day or two to see if somebody on the list replies, and then there's always a chance that I forget it, right? I mean, if if I see any reply, and sometimes the reply might be, yeah, I had the same problem. Well, I see that there's a reply out there, so I don't go look to see if I need to give an answer because there was a reply. So somebody might need to tell me, hey, this is not actually an answer. It's just people piling on the question.
Well, that sounds good. He's not a real keener on being online and stuff like that. So,
what?
But oh yeah, he's not a internet shopper like me.
Well, it sounds like what you're putting together is really cool. I would love to have a better understanding of the information coming out of my car and being able to do more with it. So it seems like a super cool project. I'd love to kind of hear more of the details about the individual sensors and and what the cape looks like and other stuff to help move the software forward. I want one.
Yeah, well, the cape actually includes a GPS, so it can tell you exactly where it is.
Wow, even better.
And of course, I think now he's fairly confident that all the showstopper issues are ironed out, and he expects that the software development will actually proceed quite quickly from here on out. The way we've structured the program, or the two applications, they are not complicated. It was really a matter of getting over the hurdle of getting through that learning curve of all the software infrastructure that's necessary to develop these things. But as far as programming the actual applications, he thinks that's very trivial.
Cool. Yeah, I mean, having all the base drivers and everything there for everybody already is going to be a big lift. Is this something? I mean, is this board going to be available to other people? And is there like the goal? You're going to build a community of users looking to do a lot of this collaboration on internet connected car.
Yeah, I mean, this is Christian's vision of it is that this is a sort of a whole open source platform that we can really get a lot of people involved in improving and working on. Certainly, we'll publish whatever we can. It's for me, it's a bit of a learning curve how to do all that, publish and get this thing going as a community project. But I'm certainly open to publishing it and making it available, and getting it sort of as an open source community. But for me, that's going to be a bit of a learning curve.
Yeah, the Element 14 site has some pretty good collaboration tools to build upon. So I would think that would be a pretty reasonable place to get started in building some of the community around this. And of course, tools like GitHub. I can't sing the praises of Git enough. That's I don't know if you guys are doing version control of your software in Git, but I would highly encourage you to do so.
We haven't done anything with Git. I mean, I have an account there, but I haven't put this project there or anything like that yet.
No. It's a great way to, the issue tracker and the pull requests. The pull requests are the real magic, right? That you can get the changes and do code reviews and pull other people's codes in. And especially if you have if you're separate to a bunch of different applications, it's a nice place to kind of point to other people's applications as well that are built on top of your software.
Yeah, that would be good. So that everybody's aware of what's connected.
Well, thank you for answering my questions. Thanks.
Christian, you have anything to add, or yeah, go ahead.
Yeah, for Jason, obviously you're the BigOnBlack when you launched the product and you launched the whole BeagleBone organization, was this the sort of direction that you would hope that it would reach into virtually everywhere? I mean, we're talking about BigOnBlack being used. I've seen it being used in IoT applications. Seen it used in. I even once met at the same event that Doug and I went to, Embedded World. I met a guy who's a particle physicist who uses BigOnBlack to control the devices for testing that he uses. What was the vision around BeagleBone? Is this the sort of thing that you were hoping that it would reach into?
Absolutely. So it's a computer. So where is a computer useful? My goal is to really kind of blur the lines a bit more between between computers and more traditional embedded. So even though microcontroller is a computer, it's missing a lot of the features that that you expect to have in a computer. The other thing is desktop computers are missing a lot of the things that you have in a traditional embedded system, right? They're missing a lot of the I/O capabilities, and so what can you do with an affordable computer that has all the low-level I/O capabilities? So I think that's there's a huge number of things. So yeah, I always anticipated there being a lot of different applications for the BeagleBone. And we started out for BeagleBoard being focused on enabling development with Linux, because it really was able to give you the desktop experience and a lot of these things that you're used to with computers. And with the BeagleBone, we just got a lot more flexible in terms of a lot of those microcontroller-like peripherals, like the CAN bus, like the pulse width modulators, like the PRUs. So in a vehicle was absolutely an internet-connected vehicles was absolutely the type of thing that we'd expect it to be used for. But yeah, I mean, home security and home automation, and I like to try to avoid dropping the IoT term, because it's not really a space in itself. I mean, you can internet connect anything, but what's the real application? What's the information? What's the interesting use of it? And home automation is something that people think of a lot when they're really thinking of when they say IoT, they really mean something like home automation, home security, and robots are a lot more than just something that roams around and tries to clean the floor. Everything's not Rosie the robot, right? So all these 3D printers, CNC machines, these manufacturing equipment, all of those are robots, even if they don't roll around. Not every robot's mobile. If you open up the door for me to start talking about applications for BeagleBone, we'll be here for another a week.
Yeah, it certainly is a great platform for just about anything you can imagine. It really has sort of the right mix of power and the right form factor. There aren't very many things out there that are like that, which have everything you might want. And it's, for me, it was a bit of a thing. I wanted to try and keep the ability to use the HDMI cape that's built into it.
Yeah.
However, the software guy doesn't use that, but I left those pins unused in terms of my cape. So the cape uses virtually every other pin except the ones used by HDMI.
Cool.
Is there a particular reason for that? You just wanted to be able to plug a display in, or what?
Well, yeah, it has this neat HDMI video capability, so I wanted to retain that. Even though my application doesn't use it, I'm assuming that other people, when they start using this, will find ways to use the HDMI output.
Yeah, I know you've got your little SPI display, but maybe somebody wants a larger display, a status display in their console already. A lot of people put these HDMI capable displays in their head units. So
yeah, so my thing is I wanted it to be able to go stand alone in a vehicle, but there's going to be lots of applications for people to use them in their houses and so on.
I do wonder a little bit about risks associated with plugging it into your car, because our colleague from Cisco, when we were formulating this project, he plugged a device into his car to talk about the information that was going to come out of it, and he said, wish me luck, it could very well scramble the computer in my car and I might not be able to go home. Was there just that sort of risk associated with this, or did nothing like that has happened?
Well, it's certainly a concern, but there's a couple of things. I think a lot of car vehicle manufacturers sort of separate that OBD port from the rest of their CAN bus, so they have more than one CAN bus running in there in a lot of vehicles, just for that reason, because they don't know what people are going to plug in there.
Yeah.
But also, we're mainly using it to, the same way a normal troubleshooting device would use it. Hopefully, we're not going to be stressing it out. But I've had some experience with using this before, and a couple of friends of mine have hooked their OBD ports up to their PC and just tried to go crazy getting data out of it. So I've seen it work, and they've never really been able to cause a problem for their vehicles. There was one guy who was trying to use it to, rewrite some of his engine firmware, but he knew what he was doing.
To cut that governor, right? So they can.
He was trying to change the timing and so on, and just go crazy.
Well, how much of this information is really open? I mean, how much can you get to? I've been curious about doing some of this stuff for a while, but I've always gotten the impression that a lot of the information, you have to pay fees in order to get access to the data information on like how the data is stored, or how to analyze any of the information.
That's very true. The vehicle manufacturers don't really open it up that well. You can subscribe if you're a mechanic. You can pay $5,000 or $6,000 a year for a subscription to all their latest data. So it's diagnostic data, but there still is quite a bit of information, and certainly enough to get started on here. I think I have several thousand codes that I can understand at this point.
That's cool. That'll be really exciting to see what some of that information is, and see what type of things we can data log and learn from our cars.
One of the things we can't do yet, of course, is know exactly how a vehicle will respond to a failure within the vehicle. So it will generate some kind of error code, but we don't want to make our cars fail so that we can figure out exactly So they're
just gonna go in there and start cutting cables, just like
we will make some assumptions at this point, but as people learn what's really going on there, it will be easy to upgrade the system to be able to simulate that more accurately.
And one of the challenges I'm curious about is the differences between different types of cars. Or I would imagine that there's a European standard of car, and then there's an American standard and Japanese standard. What kind of hurdles does that throw up?
There's several different interfaces built into that OBD port. So there's this K-line interface, as well as the sort of CAN bus ISO stuff, and we haven't actually played around with that K-line. I built the hardware, so it's got K-line as well, but we haven't tried it. We don't have any cars that run on that system. So I don't know yet. Definitely the capability is within this machine to simulate both and deal with both, but we haven't actually done it yet.
I was going to say, I own a French car, and it's probably got the weirdest system of any car that I've ever owned before. So it does everything in a unique way. So I was wondering how it could diagnose problems in my car.
Well, the automotive industry has actually made a lot of standards, and it's pretty good. There's a core set of codes that are the same for everybody, pretty much the same for everybody. And then, of course, they have all the manufacturer-specific stuff. But the core functionality in a vehicle is actually covered by the core function. So those things that are manufacturer specific are they're not that important in terms of vehicle functioning in general. So it's certainly an adequate set of codes to work with for a normal simulation. But we still have some manufacturers' codes available. They're not all secret or anything. It's just a matter of digging them out.
Okay.
Any other thoughts or questions before we sign off?
Have you thought about like what some of the killer apps might be? Like I don't know. Is it tracking your kids, how much they break the speed limit? Combine the GPS data with the speed limit database and find out how often they exceed the speed limit, or what type of things do you see as kind of some of the killer apps?
Well, I actually have been thinking about that quite a bit, and I've come up with a couple of killer apps, but unfortunately, I'm not really willing to talk about them.
They must be really good then.
So I'm happy to make the simulator open source, but not the killer apps.
I think though that's perhaps the point of the whole project is the fact that that your achievement of this when it's finally there is going to enable the individual or the groups of individuals to make these killer apps. And I think that's the reason why we undertook the project, why Cisco and we commissioned this. We want to democratize this development and make it more open.
Well, you can't blame me for asking it, but now it seems like you're enabling yourself and a lot of other people to come and make those things, and so I'm excited to see it. Is there any other timeline information before we wrap up?
Yeah, I actually expected to be further ahead than we are right now. So I'm hoping that it's unfortunately I don't have full control because I got a software partner here, but I'm hoping that we will have something shortly in the next few weeks. That I'm certainly expecting to put updates to the blog on the development within the next couple of weeks, and hopefully it'll be actually a first working system within a month. I'm just throwing a number out there, but I really expect it to be there.
Well, this is super cool.
For anyone who is interested, you can check out element14.com for those updates. And unless anyone has anything else, I will thank you all for your time. This was productive and interesting. Thanks so much. I know you're all quite busy. And with that, I guess we'll close down the Hangout.
Thank you.
All right, it was good talking
Bye,
to
everyone.
you.
Take care.
Bye-bye.
Bye.
Bye-bye.